welcome back to my channel. In this video, I'm gonna discuss about the best time to buy and sell stock. Where in this problem we are initially given with an array prices where the index represents its day and also the value represents the stock price. And at day 0 we have the stock price as 7, and at day 1 we have the stock price as 1, and etc. And the main requirement for this problem is to figure out the maximum profit that we can make from this prices array, and quickly simulate the maximum profit that we can get from this prices array. Initially, the most brute force way is to figure out like what is the maximum profit when I buy it here, and when I buy and sell at the same day I'm gonna get the profit of 0. But when I sell at the index, sorry, day 1, I'm gonna get a loss of -6, and at here -2, and at here -4, -1, and -3. And among all this, the maximum profit that I can note is 0, right? And therefore I'm gonna move it further, like it's done with the day 0. I'm gonna move it further, and for the same day the profit is 0. Here when I sell at 5 and buy at 1, the profit I can get is 4. Here it is 2, here it is 5, and here it is 3. And see here, the maximum the maximum profit that here I can get is 5, and the remaining is the previous one is 0, which is lesser, therefore I have to update it. Done with the day 1, I'm gonna move it for the next day. Standing at here, same day cost me 0, the profit is 0. At here I get a loss of -2, here a profit of 1, here again a loss of -1. Got it? Therefore I'm not gonna update it because its value is still less than 5. And we are done with the second, and we are gonna move to the third day. The profit is 0, here it is 3, and here it is 1, and it's still less than the maximum profit that I have seen earlier. Therefore I'm not gonna update the maximum profit here. I'm gonna move it further. When I buy it here and sell it here, the maximum profit is 0, and when I do it here, the maximum profit is -2. Therefore I'm not gonna update it. And done the same thing, therefore I move it further. Here it is 0 because I cannot sell at the previous days. I cannot go back in time. Therefore the maximum profit for this day is 0 itself, and I have to return this maximum profit. And let's quickly write the brute force approach into the code form. Therefore we're gonna move, like I have to stand at one index, which will go from 0 to the n. Where the n is the length of the price, and the second loop starts from, we can say that, yeah, from j, which starts from I itself and goes till the end. And you're gonna check that if the prices of j minus the prices of I, if it is greater than if it's greater than the maximum profit, and initialize the maximum profit to some element, like you can initialize it to 0, because when we buy and sell at the same day, we're gonna get the maximum profit as 0 itself, right? We're not gonna get a negative. Therefore, in this case I'm gonna update the maximum profit to the value that is same as here, which is prices of j minus prices of I, and at the end of remaining I'm gonna return the maximum profit. And let's quickly analyze the time and space complexity for this approach. The time complexity is the outer loop runs for a time complexity of order of n, and the inner also does the same. Therefore it's a nested one, and we'll get a time complexity overall of order of n cross n, which is order of n square. But in the constraints of this problem, they are given that the maximum length that the prices array is 10 power of 5. But order of n square solution is not feasible for this. It's gonna give us ATL. Therefore, forgot the space complexity for this is order of 1, because we are not using any external data structure. Therefore it's gonna give us TLE. And let's move towards the optimal solution. And here the optimal solution is greedy one, and I have to make sure that there are two variables. One is the maximum profit and also the minimum cost price, like the minimum cost. and initially set this to 0 because when we buy and sell it the same day, we're gonna get the maximum profit as 0, and the minimum cost is the first element, right, 7 here. And when I am at here, the minimum cost is still 7. I'm gonna do that current stock price minus the minimum that I have seen for. I will gonna check that whether this thing will give me the maximum profit or not. And let's simulate this with every element that is present in the prices array, which is the current price is 7 and the minimum we have seen so far is 7, which is 7 minus 7 0. And for this, here we can see that 1 is lesser than my minimum cost that we have seen so far. Therefore, I'm going to update it with 1. And we're going to do the same thing. The current price is 1, the minimum is 1, both are 0. Move it further. 5, which is greater than the minimum cost, not going to update it. Therefore, the current price is 5 minus the minimum is 1, which is 4. The maximum profit you can get is 4. I'm going to update it because it is greater than 0. Move it further. It's 3, still greater than the minimum cost. I'm going to get a profit of 2, which is smaller than the maximum profit. Not going to update it. Move it still further. 6 minus current stock is 6 minus the minimum cost is 1, 5. This is greater than the maximum profit. Therefore, I'm going to update it. Move it further. 4 minus 1, which is 3. Still lesser than the maximum profit. Therefore, I'm done. I'm out of the array. Therefore, I'm going to return the maximum profit. And let's quickly simulate the pseudocode for this object. As I said earlier, we're going to pick two variables, maximum profit and minimum cost, and we start at the index 0. At index 0, the minimum cost is 7 because it's the starting element, right? Therefore, I'm going to move in the prices from I, which goes from 0 to the length of the array. And if we're going to check that if the prices, the current price, if prices of I, if it is lesser than the minimum cost that I have, therefore I'm going to update it, right? Minimum cost is the price, and I'm going to make sure that the maximum profit should be updated accordingly. The maximum profit is updated only if it is greater than the current value, which is 0. Therefore, it is the maximum of the previous one, which is the maximum profit itself, and the difference of the current is prices of I minus minimum cost. And at the end, I'm gonna return the maximum profit. Discuss the time and space complexity for this approach. If I look at here, the time complexity for this loop, it takes its order of n, and remaining all takes order of 1 because it's comparing and updating the variable. And this is the time complexity. The space complexity is still order of 1 because we are not using any external data structure. Yeah, this is the most optimal solution. And if you understand everything, please do like and share and subscribe. Thank you.